All right, so here we're supposed to use the definition of continuity to discuss the continuity of the function whose graph is shown here. All right, so basically, where is it continuous or not continuous in this case? It looks like we have a break in the graph here, if it'll let me draw it. We have a break at this point. We have a break at this point. We have a break at this point. So there's 4 places where it's not continuous. So not continuous at. And then we have x is equal to, looks like a -3, a -1, a 2, and a 4. Okay, so what we're going to do is we're going to look at those points and kind of say why they aren't continuous based on the definition of continuity. So at x equals -3, well, the limit of f of x as x approaches the -3 is going to be what? Well, as it approaches the -3, coming from the left, it gets close to 3. As it comes from the right, it's close to 3. So it looks like that limit is equal to 3. So that works. But what is f of a -3? Well, it doesn't exist because we have an open spot there. So that does not exist. And this is why it's discontinuous at that point. What about at x equals a -1? Well, again, limit of f of x as x approaches a -1 is equal to what? Well, a -1, it's coming here, it's approaching from the left, it's going to be, in this case, it's not going to be the same. So here we're going to have to go from the left, and here we're also going to have to limit of f of x as x approaches -1 from the right, and it's going to be something different because from the left, it's going to be a 1. From the right, it's going to be a 2. And because of that, the limit doesn't exist at x approaches a -1. Okay. And so that's what they have. But now, can we find f of a -1? Well, we can because that point here actually is truly a point. It has a solid dot here. So that's equal to 1. All right, so our limit doesn't exist, but we can find the point there. And so because they are not the same, then it's discontinuous. Now, what about x equals 2? All right, so here, x equals 2, it's going to be kind of the same thing, except this time the limit of f of x as x approaches a 2 is going to be equal to what? Well, as it comes from the left, it equals 5. Comes from the right, it equals 5. So that's equal to 5. So that's okay. Now, what about if we plug in f of a 2? What do we get? Well, f of 2 is actually going to be 1, 2, 3. It's going to be equal to 3. Okay. And those don't match. And because of that, we have a discontinuity at that point in the graph. And our last one then we have is x equals 4. And so here again, we have 2 directions. So we're going to have the limit of f of x as x approaches 4 from the right, and the limit of f of x as x approaches 4 from the left. And so from the right, it's going to be, looks like 2. From the left, it looks like it's going to be a 4. And so basically, we have the limit of f of x as x approaches 4 does not exist because those have to be equal to make it work, and those are not equal, and so the limit doesn't exist. And what about f of 4? Does that exist? Well, this time that doesn't exist either, and so we have that does not exist as well. Okay, so that's how we can look at discontinuities for looking with the limits, as well as, at plugging in a point in the actual problem. All right, how about this one? Using the definition of continuity, discuss the continuity of each of the functions at the indicated points. All right, so f of x equals x plus 1, x equals 1. Well, it's going to be a polynomial. It's going to be continuous a line there. It doesn't say there's any breaks in it. So basically we have for 1, it's going to be f is continuous at x equals 1. And what do we get? I can write up the hill. F of x is equal to, or actually f of 1. Where's my mouse here? There we go. So f of 1 is equal to what? Well, it's 1 plus 1 or 2. Okay. So that would be what we have here. What about 2? So now we have x squared minus 1 over x minus 1, and we want to add the um, x equals 1. Well, if we think about that, that is going to have an x plus 1, x minus 1 over x minus 1. Okay. So it's not going to actually have a definition at the x equals 1. So f of 1 does not exist, is not defined, I guess we could say. Maybe that would be a better way to do it, not defined. Okay. But it's going to be also not continuous because you're going to have that break in the graph at that point. So it's going to have the g is not continuous. Okay, and that's because this is not defined. All right. 3. Now, if we want to add x equals 2 and x equals 0, so there's two possibles here. So at x equals 2, well, if we plug in 2 here, we're going to get 0 in the denominator. And so h of 2 not defined. Okay. And so basically, what we're going to have is it's going to be coming in from two different directions. And so your limit is not going to be defined because from one direction, I think we've done one like this before. It's going to be up here and the other one is going to be down here. And so you're going to have differences here. So this isn't defined. And also the limit of f of x is not defined at that point as well. So mainly you can be not continuous because of this and be done with it, but you could also take it and do the limit as well and show that it's not defined there as well, and so it's not continuous due to that. What about at x equals 0? Well, at x equals 0, then that's just going to be a negative 2 over a positive 2, so that's just going to be a negative 1, and so basically h of 0 equals 1. Now, what about the limits? Because now we also have to show that. So limit of f of x as x approaches 1 from the left is equal to what? And the limit of f of x as x approaches 1 from the right is equal to what? And so what we're going to have to do is we're going to have to plug that in. And so we would do a table. We could also look at the graph of this. But if we plug in from the left, that's going to be a negative 1. And that's also going to be negative 1. And that's also going to be a negative 1. And because those two are equal, then the limit of f of x is equal to negative 1 as x approaches 1. Okay. And so that's going to be kind of a key thing. And so that would be what we have. And also, by definition, if we don't get a 0 in the denominator and it's not going to be 0 in the numerator, then what's going to happen is it's just going to be whatever you plug in the 0, you get a negative 1 out for your answer. And so that works. And so, that's going to be what that is there. So, yeah, so that's the negative. Where'd my negative go? It disappeared there because that's a negative 2 over that. All right. So yeah, so it's negative, negative, it's negative throughout. So that's how that one works. All right. So, that's that. Now let's come back in a little bit and do some more definitions.